Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video I'm going to go over a few applications of the Pythagorean Theorem. Just a quick reminder that if you have a right triangle, which again is a triangle that has a 90-degree angle in it, and the two legs are labeled as A and B, and the hypotenuse is labeled as C, we know that A squared plus B squared is equal to C squared. Chicago is located 229 miles north and 136 miles east of St. Louis. What is the direct distance between the two cities? So let's say this is St. Louis. Chicago is 229 miles north and 136 miles east. Something like this. So again, that's 229 miles north and 136 miles east. And the question is, what is the direct distance between the two cities? And that's right there. We know that north and east forms a right triangle. So we have a right triangle where we know the two legs, but we're missing the hypotenuse. So we'll use the Pythagorean theorem, a squared plus b squared equals c squared. We'll let a be the 229. We'll let b be 136, although it doesn't matter which is which. Next we want to compute 229 squared plus 136 squared. And that is equal to 70,937. Now to figure out what c is, we'll just take the square root of both sides. Again, we'll ignore the negative square root because the distance cannot be a negative distance. The square root, let me use the approximately equal sign here. The square root of 70,937 rounded to 2 decimal places is 266.34 miles. Okay. Let's try the second problem here. An 8-foot ladder is leaning against a wall. If the bottom of the ladder is 2 feet from the base of the wall, how high up the wall is the top of the ladder? Well, a picture's a great idea. Let's draw a wall first. And on the floor, we have a ladder that leans against the wall. Now we're told that the ladder is 8 feet tall, and we know that the base of the ladder is 2 feet from the wall. We have a right triangle here. The wall and the floor form a 90-degree angle. We know the hypotenuse. We're missing one of the sides. So for the Pythagorean theorem, a squared plus b squared equals c squared, I don't know the first leg. I know the second leg is 2, and the hypotenuse is 8. It's going to give me a squared plus 4 equals 64. Subtract it over the 4. A squared equals 60. And again, we'll solve this by taking the square root of both sides. We only need the positive square root because the height on the wall has to be a positive distance. Square root of 60 I don't know, but I do know that 60 is 4 times 15. And I know the square root of 4 is 2, so this is 2 square root of 15. And we can approximate this. Let's round this to the nearest hundredth of a foot. That's 7.75 feet. As I mentioned in a prior video, if you're going to use the calculator anyway, you could have done it right from here. The square root of 60 is approximately 7.75. All right, let's try one more problem. This one's got a little more to it. A 50-foot guy wire runs from the top of a pole to a spot on the ground. If the height of the pole is 6 feet more than the distance from the pole to the spot the guy wire is anchored, how tall is the pole? So let's draw a picture here. Do we know what that is? Yes, that's a pole. And there's a wire from the top of the pole that's coming down to hold the pole secure. So again, here's the pole and the wire. And this is the ground. Assuming the pole is vertical, this is a right triangle with the ground. And we're told that the wire is 50 feet long. The only other thing we know is that the height of the pole is 6 feet more than the distance on the ground. So if I let the distance on the ground be x, the height of the pole is x plus 6. So in the Pythagorean theorem, the two legs are x and x plus 6, and the hypotenuse is 50. So I'm going to have x squared plus x plus 6 squared equals 50 squared. All right, let me rewrite this on the next screen so that we can solve it. First, to square this binomial, we need to multiply it by itself. So I've got x squared plus x plus 6 times x plus 6 equal to 50 squared is 2,500. We're going to multiply this out, and that is equal to x squared plus 6x, and 6x is 12x plus 36, and that equals 2,500. I'm going to go ahead and combine the like terms, and at the same time I'm going to subtract 2,500 from both sides so that we'll have our quadratic expression equal to 0. 2x squared plus 12x minus 2,464 equals 0. First, we notice that there's a common factor of 2 that I can divide out from each term. 2,464 divided by 2 is 1,232. Now, I would take about 5 seconds trying to factor this quadratic expression. I can't do it that quickly, so it's time to go to the quadratic formula. You could also use completing the square if you like. I'm going to use quadratic formula with a being 1, not the a from the Pythagorean theorem. The linear term's coefficient is 6, and the constant is negative 1,232. So x is equal to the opposite of b, negative 6, plus or minus the square root of b squared, 6 squared, minus 4 times 1 times negative 1,232. And that's all going to be divided by 2 times 1. I need to simplify the radicand. 6 squared is 36. When I multiply this all out, I get 4,928 plus the 36. 4,964. I know that to simplify this, I happen to know that I could factor out a 4. The square root of 4 is 2. So I have negative 6 plus or minus 2 times the square root of 1,241, all divided by 2. I can divide out a common factor of 2 to simplify this a little bit. And so my solutions are of the form x equals negative 3 plus or minus the square root of 1,241. Now a little bit about this. Negative 3 minus the square root will give us a negative value for x, and we know the height of the pole can't be negative. So negative 3 plus 1,241, that is approximately 32.2 feet. If you recall, in our drawing, that was the distance on the ground. The height of the pole was x plus 6. So if I add 32.2 plus 6, I find that the height of the pole is 38.2 feet. For those of you doing your MyMathLab homework, I think you'll really appreciate this help. If you have any questions or comments on this video, these problems, or this topic, or if you've got a request for a video I can put together for you on YouTube, you can reach me through the contact page on my website, and that address is georgewoodbury.com. Thanks for watching, and good luck with these.